In this problem, we're looking at what happens to the sulfur and showing that it's being reduced, what happens to its oxidation number. Now there's two things we can look at. We can do this by oxidation number. We can also do this by half reaction. So if we're looking at oxidation number, we would start off with the SO4 minus 2. We know the oxygen part of this. There are 4 of them with a minus 2 charge for each. Overall, there's a minus 2 charge, and we have one sulfur, which I'll make X here. So we end up with X minus 8 equals negative 2, and after rearranging, I end up here with X equals plus 6. I take a look at the SO3, that's later in the reaction. Same setup. We have 3 of the oxygen at minus 2, overall charge is minus 2, and X for the one sulfur. So X minus 6 equals negative 2. When I move the 6 over, I get X equals plus 4. So we can see as we go from here to here, we are reduced. In order to reduce from plus 6 to plus 4, that means we gain 2 electrons. Now, we can look at this problem as well as a half reaction to see the same process. We have SO4 minus 2 going to form SO3 minus 2. The first step is you balance your main element, which is the sulfur, and we can see that that already balances. So I go on to the second step of this process. It's SO4 to SO3 minus 2, and the oxygens aren't balanced, so I'm going to add one oxygen to balance off that by adding water. Now, in order to balance the hydrogens, we're going to add hydrogen ions to the other side. So we have SO4 minus 2 plus 2 hydrogen ions gives us SO3 minus 2 plus H2O. So we're going to look at the charge on both sides. We have a minus 2 and then 2 plus 1s, or plus 2, for a total of 0 on the left side. We have minus 2 on the right side. So in order for this to balance, I'm going to have SO4 minus 2 plus 2H plus, and I have to add my 2 electrons here in order to get my SO3 minus 2 plus H2O. And that balances. Again, we can see it's being reduced because the electrons are on the left side, so it's being reduced by 2 electrons.